So now you have not still yet fully DNA double strand, because you still have the RNA nucleotide over here, which must be replaced with DNA nucleotides. Okay, so the function of DNA polymerase tree is to add free DNA nucleotides to the short RNA primer by adding complementary DNA nucleotides to the bases of the template. So RNA primer contains RNA nucleotides which must be replaced by DNA nucleotides. So now we need another enzyme, namely DNA polymerase 1. Okay, so DNA polymerase 1 will replace the RNA nucleotides with DNA nucleotides. So it will bind to the regions where RNA primer is located, and then it will replace the nucleotides with the DNA nucleotides. And the process will continue until all the RNA nucleotides has been replaced. But the DNA polymerase 1 only replacing the RNA nucleotides. So it doesn't actually join the fragments. So you still have fragmented DNA. So what will happen next is the fifth step, which is the last step, is to join the Okazaki fragments. So now you need another enzyme, namely DNA ligase. So the DNA ligase joins the Okazaki fragments by catalyzing the formation of phosphodiester bond between the adjacent Okazaki fragments. So it will bind to the distance between the fragments, and what happens is that it forms a new phosphodiester bond between the sugar and the phosphate group. So once the phosphodiester bond is formed, you have two continuous identical copies of DNA are produced. And that's the end step of the DNA replication. So you need to recall in mind that the DNA replication process involves 5 steps. Step 1 is separation of DNA double helix. Step 2 is to build RNA primer. Step 3, you need DNA synthesis. And then step 4 is to replace the RNA primer. And the last one is to join the Okazaki fragments. So I hope you can understand my explanation, and hopefully it can help you to understand the processes. Okay, so I end this session. Thank you.